the systems that we're today. All right. So, and I was very deliberate about like the title of this presentation because I understand some of the sentiments that's carried in the community around Kubernetes. So this is probably how a lot of you feel. And I appreciate there's actually so many people here that came to that talk. And so we'll see this come up a couple of times. Before I continue with the slides, I'll go ahead and just share what will be the GitHub repo that my code examples will be coming from. Actually, I shared that with you, Neil, if you could put that in the chat for me.
Yep, I'll get it.
And I thought this might come across a little harsh sounding, like if you pronounce it out loud, but if it makes you feel better, I also have the .NET one as well. So I'm like equal parties on this one. So I'm playing no favorites. So let me jump back over to here. All right, so what is Kubernetes? Now, a few years ago, entering this ecosystem, Kubernetes, containers, Docker, whole flurry of vocabulary being thrown around. And if you go to the main Kubernetes website right now, this is what you'll see: an open source system for automating deployment, scaling, and management of containerized applications. And if you're anything like I was, I read that and had no idea what this meant. And when you descend into the docs, it doesn't really help. It like is just continuing to like be like drinking from the fire hose as you descend further into the documentation. And again, why, right? Like why are we sitting here talking about this? Like, hey, I get it. Like Kubernetes is the next big thing, but like I'm already struggling with my VMs, man. Like I don't need this extra layer of abstraction here. Or like I've heard that even just trying to keep this thing alive is just gonna cause like an early grave for me. So I don't really want that. And for a moment, I will appeal maybe just to some market numbers, just very briefly, about this really being surprisingly the second largest open source project in the world after Linux, which is, I thought, kind of interesting. But furthermore, Gartner did this study on containerization technologies and whatnot. And what they identified is that by 2027, more than 90% of global organizations will be running containerized applications in production. Now, that doesn't necessarily mean that those containerized applications are in Kubernetes. There's plenty of other amazing products. ECS, for example, pretty much all of the major cloud providers have their hosted container service. So I don't think that this 90% was Kubernetes specific. But really more specifically about how Kubernetes is already the primary container orchestration for 71% of Fortune 100 companies. So whether you like it or not, it's one of these technologies that is already present, expected to grow. And so maybe let's be kind to ourselves. Let's take it a little bit slower and let's digest some of the material that it's pushing out there. And I think hopefully that will give everybody a more pleasant experience the next time that you're staring down the beast. All right, so what are the goals for today? I think it's important to establish goals just so we kind of understand the scope of things. So the goals for today are to discuss these big ideas. We're going to be hands-on, so the repo that was hopefully shared out, we'll be following along with that. And also to think differently about Kubernetes. Maybe it's not this like bad, evil thing that some people crack it up to be. Non-goals, knowing what we're not going to cover is just as important, I feel. So I'm not going to explain containers. I'm not going to demonstrate application migrations. Here is my like WebSphere application written in 1992 that I want to now put in my Kubernetes cluster. How do I do that? That is a different talk. Day two concerns, we're not really going to be talking about what is it like to actually run an application in Kubernetes. And then I'm not even really going to touch on best practices. Because this is not a talk on Kubernetes specifically, but more about the concepts behind it. So with all that laid out, I will say that one of my goals is that I'm hoping to get through this without also confusing myself. And as we go along, feel free to ask questions. I know Neil, I believe, is like keeping an eye on the chat. So comment, question, don't wait till the end. If it feels like it doesn't apply for what I'm talking about, we'll probably hold off. But otherwise, feel free to jump in. Yeah, I like having interactive sessions. So if I was to give like the buzzwords, like the buzzword headline for this presentation, it'd be like the thing that nobody wants you to know. And that is Kubernetes is an API. First and foremost, it is a CRUD JSON API, and I would argue it's perhaps one of the cruddiest of CRUD JSON APIs that I've ever worked with. And when I say CRUD, I mean it is very adherent to this whole create, read, update, delete. We're getting like borderline, like Helios, like interjected in here as well. But like, hopefully, when I say this is an API, for most people here, this is already evoking some like sense of what that means. So in all of my examples, we'll see I'm using Spring Boot for these examples. But yeah, Kubernetes is an API. And if I was to like start putting some like squares and stick figures and stuff like that around some stuff, here is like the generic API diagram. I have a 3-year-old son, so some of these slides I did while he was present. So if things look super elementary, it's probably because he was in the room, and my whole day is basically shapes and colors and things like that anyways. So here's our generic API diagram. We have like some application, some service that is the API itself. It carries our business logic. It exposes those HTTP endpoints. We have a client external to the system that interacts with that API. So we make requests and the API sends responses. And then the API has a dedicated database as it's for storing the resources that we're manipulating. So this is Kubernetes in a nutshell. Now, there are a few differences that we're going to start touching on between Kubernetes and those APIs that you might be building at work, for example. And the first one comes to like, what are the things that we are storing in the database? So Kubernetes doesn't have resources like customer or invoice or anything like that. Instead, it has things like container, or maybe the firewall rule table, the IP configuration table. So the information that we store in the database, still resources, still these, everything we think about when it comes to domain-driven design and entities, and this vocabulary still applies here. It's just what we're saving is perhaps a little bit different. It's very infrastructure focused. And there's like one more critical thing that really kind of activates this whole system and makes it from a generic API to Kubernetes itself. Now, I'm missing some room in this diagram, so we have to make some room. I did this next slide when I was watching The Office, and if anybody is an Office fan, there's like this episode where Dwight has appendicitis and he's like lifting up the projector and like yowling in pain. And so this is what I thought of. And so I'll do the voice along with it as well, because he goes, ah, to like pull that projector down. It's funny. It's funny. And this is the last thing that we're missing in our diagram right here. This very cute robot looking creature that we will call controller. And I'm going to give some clarity to this name in a moment here. Now, you might think this controller maybe has some special protocol that it uses to communicate with the API. Like, surely there's got to be some hidden magic here. But nope, just HTTP. So everything, like as we start to get into it, everything that interacts with this API server, it's just HTTP, where you just send it along, get posts, puts, updates, patches, the whole 9 yards, sending and receiving JSON. So controllers interacting with the exact same API that our clients use, getting communicating with HTTP. Okay. This is probably the scariest slides that I'll show throughout the entire presentation. And again, I tried to make it friendly with colors and shapes and things like that. But this term controller, what does it mean? What is this component doing? I was following you along so far. We had client API database. I don't know what this controller does. So my academic background is in electrical engineering, and there's this subfield of like engineering / applied mathematics called control systems, control theory. And control systems is all about basically managing dynamic mechanical systems traditionally. So things like robots or spaceships, right? Like segways, like the math and basically the engineering that allows some of these like really cool mechanical things to happen is all in this world of control systems. And so this term controller comes directly out of this field of engineering. And what I'm showing on this screen right now is kind of like the idealized block diagram for a closed loop control system. Again, this sounds really scary, but we're going to start breaking this down. You're going to see that, and like next thing you know, you're going to be driving home and you're going to be seeing closed loop control systems everywhere, like on your drive back home. So sorry for that. Let's add some annotations around things. So one of the defining characteristics of a closed loop control system is that there is this concept of feedback. So we're taking the actual state, which could represent like maybe I want my segue, right, like angled at a certain angle relative to the Earth. So there's my actual state where it's at right now. We take that information and feed it back into the desired state. So we have this block down here basically represents like the thing that will measure the actual state, and that produces our observed state. We then have our desired state. So usually that's, for example, human set or something like that. I want this to be the state. And then we have this other little piece right here that's going to take these two things. I have my desired state. I have the state I've observed. What's the difference between these things? Whoops, I accidentally went back a slide. What's the difference between these things? And then there's like one final component that takes this difference and then does something, performs an action to try to bring our actual state closer to our desired state. Now, anybody looking at this, and if you're somebody that's worked within this like DevOps, like platform infrastructure kind of space, just probably maybe thinking about some of these infrastructure as code tools, like Terraform, for example, CloudFormation. Like a lot of these infrastructure as code tools are built on the same exact concept. We have a desired state. I want this VM to be running. We have the actual state. I don't have a VM running. And so these tools are measuring those, calculating what needs to happen, and then performing that action so that way what's actually happening matches what my desired state is. Now, within Kubernetes and in all of these examples and these blocks that we're looking at right here, these are going to just be functions, like functions in code. We're going to have a function that measures the state. We're going to have a function that computes the diff. We're going to have a function that performs some actions. So when we start getting into the code examples, just kind of think about this block diagram as we start stepping through it. A note on terminology here. So within the Kubernetes docs, they'll use this word reconciliation. And when they talk about reconciliation, this is what they're referring to. So we say that the controller reconciles the state. The controller is the thing that is looking at this actual state, desired state, basically implementing this closed loop control system. And then just kind of as like a final, like simplifying example, like when I said you're going to see these things everywhere you go now, just think about like the heater, like the HVAC system for your house, right? Or even like the cruise control system in your car. We have, and I see the hand is raised, Neil. I'll get through this example and address it. But yeah, we have some like desired temperature. We have the actual temperature of the room. We have a sensor within our heating system that's measuring the temperature, figures out what needs to happen, and then some relatively simple logic here, like if my temperature is below what it needs to be, turn the heater on and then turn it off otherwise. So closed loop control systems all over the place. Go ahead, Neil.
There's a question earlier. Is the Kubernetes controller the same thing or comparable to a Spring Boot controller?
Comparable to a Spring Boot controller. So I would say different concepts. Annoyingly, in the tech world, we have so many overloaded concepts with things. When I hear controller in like the Spring Boot sense, I'm thinking of this part of the code that is receiving the request and then acting on it. Usually it is piecing together other services or things like that. So it's the thing that's receiving the request and responsible for kind of like shipping the response back out to the client, ignoring all the middleware stuff. Controller in this sense, we're going to see doesn't necessarily have a public API. I might not necessarily be able to interact with this controller. Instead, we're using the term controller because it is controlling some state. Hopefully that helps. When we get to the code examples, if it still feels confusing, we can talk about that a little bit more. All right. So scary diagram's gone. Back to our block diagrams, or I guess, I don't know, icon-driven diagrams. But so I shared with you, yeah, we have this controller, great, closed root control systems. I'm tracking so far. So what is this controller controlling in this example in Kubernetes? Well, again, remember in our database, we had these tables that were like container table, firewall rule table, IP configuration table, right? We have these tables, and what these represent is our desired state. So what we're putting into the database is our desired state of the system that we're trying to control. Now, just knowing what the desired state isn't especially useful. I guess this controller could read the data, but it can't really do much on its own. So there's one other thing it has to do, which is to act on the outside world. And so following with this container table, we're going to rename this to the container controller, and we're going to add one last piece to this diagram, which is I threw the Docker whale in here. So if I have the desired state of my containers and I need to start some containers or take away some containers, I need to be able to interact with the container runtime. So here I'm representing Docker. So let's draw up this closed loop control system. The client, through the API, is going to provide our desired state. That desired state gets saved in the database. And then this controller is going to be just continuously read desired state, measure actual state, do some stuff to bring them closer together. And this just goes on and on and on and on forever. So controllers, they're not like one-off jobs that run. So unlike Terraform or CloudFormation, it's not something that I choose to like trigger at some point. These run all the time. They're continuously reconciling the state. Okay, before I carry on, because the next thing we're going to look at is some of the code examples. So we're going to build our own Kubernetes with Java and Spring Boot based off of the concepts that we've talked through so far. But before I go on, any further questions on kind of like these like concepts so far? Cool. Okay. Code time. Now, I need to like pray for a moment to the demo gods, and hopefully they are kind to me. I have done everything possible, including like caching everything locally. So if my internet cut out, I won't be able to talk to you, but I will still be able to run this demo. So if anything goes wrong, I'm going to be very upset. So I believe Neil shared this. I can't see the chat right now, but this repo is public. So if you want to follow along on your own, you can run this. Whoops, this is the .NET one. Let me go back to the Java one. For this, I use JDK 21, and to follow along through all the examples fully, you will need Docker and some, for this example, we're not doing anything with Kubernetes, so you can ignore the Minikube example for simple Netties. So if you have the JDK 21 and Docker, you're good. You can follow along. Go ahead, Neil.
I have two questions in chat. Is it like IAC, but with containers?
Ooh, what was that acronym? I missed that.
I think it's inversion, or Andrea, if you could unmute, maybe it might be easier. Infrastructure. Oh, okay. Is it like infrastructure as code, but with containers?
Exactly like infrastructure as code, but with containers. However, what we'll start to get into is you'll see Kubernetes, even though it's kind of pegged as a container runtime, what makes it kind of big and daunting is the fact that we are controlling lots of things, not just controllers. So hold on to that thought. And actually, that's a perfect segue into like when we get past this demonstration, we'll start talking more about what are these different controllers that Kubernetes has. So that was an excellent question. We'll touch on that a little bit further. Go ahead. Question
All
two.
right. Second one is the controller polling the API?
Is it polling the API? In these examples, we are going to be polling the API, and you are perfectly welcome if you want to write your own controllers to pull the API, and some of the simplest controller implementations do pull the API. Polling is not awesome for performance. There are and therefore like real production grade controllers actually do have the ability to set up what are called watches, I believe. So you can say like you make an API request to create a watch and say, let me know anytime something changes. So basically you're setting up a webhook. So real controllers are kind of built around webhooks, but conceptually, if you just want to think about stuff polling periodically, that is a-okay. You'll get very far with that mental model. Alrighty.
That's all I had. Yeah.
Perfect.
Thank you.
Let's look at some code. I'll admit that I was the imposter, by the way, this whole time. I have not worked with Java in like a serious professional capacity prior to this talk. So this was an awesome like first tour into the world of Java and Spring Boot. I had a lot of fun with this. I will say debugging a missing annotation was incredibly frustrating, but I carried a lot of like preconceived notions that were completely broken down when I was working on this. Like streams are really cool. What else? Like turns out all of these examples, like they should all start up in like a second or two. So like I'm sorry, Java. Like if I have bad mouthed you in the past, I apologize, because at least JDK 21, very good, very good. So let's carry on. I probably don't have to tell everybody here, but as an outsider looking in, just very cool technology. Okay, so for this example, we're going to be looking in the simple netties folder, and then within here, this has its own README that kind of like walks you through how do you start this up, how would you want to run it, what are these endpoints that we're exposing. I'm not going to just like read this README to you, but this is here if you want to go through it on your own. I'm going to flip over to VS Code. And I will pull up the README just to borrow a couple of these commands that we're going to run. So as we were talking about within our block diagram, I need a database. So I need something to like save our desired state. So I have a little Docker Compose setup here that will run the database and the server and the controller all at once. I'm going to run these separately just for this demo, for this talk. So I'm going to go ahead and run the database. If we look in the database real quick, we'll see that this is just a bog standard like Postgres database. I'm not really doing anything special. Here's my super complicated SQL like initialization that I'm doing right here. I know, wow, it's amazing. Just creating a table, ID, name, image. Now these are containers, just because I think it's cool to actually see this in action with containers. But yeah, I'm creating a table to hold my containers. I threw a little constraint on here just to say names are unique. I'm taking a lot of shortcuts with some of these examples. I figured I was going to create a lot of these apparently, so I had to have an index, I guess. I don't know what I was thinking, but I just threw it on there just for fun. But yeah, here's kind of the meat and potatoes of our database, simple table. Okay, so our database is running, and I'm going to open up a new terminal. Now, the next thing that we're going to start running is our server, our API server. So this is also just a pretty bog standard Spring Boot application. In fact, it's pretty much just a single class here. I do have one other record. Record's very cool. Very happy to see that. I do have one records that is like basically the code representation of this database entity. Yep, just name and image. I'm not really worrying about the IDs in this API. And we have 4 endpoints here. We have an endpoint for getting containers. again, desired containers. We have an endpoint for creating a container. So I would like a container to exist. We have an endpoint for giving me information, maybe about a container I've created before. This I added just to like round out the API endpoints, but really not useful for this demo. And then I have an API endpoint to delete the containers that I've created before. So I'm going to go ahead and start the server, and then we'll run some commands just to make sure we're all comfortable with how the API server is functioning. So let's go ahead and we'll say projects server, and then I think it's Spring Boot run. So I'm just going to run this. All right, and that is already up and running. And just to demonstrate just a couple of these API endpoints, let's go ahead and like we'll call the API endpoint to like fetch my desired containers. Probably should have thrown a -s on all of these. So right now, I have not given this API any containers that I want to have running. So when I fetch my containers, we just get an empty JSON array back. So let's go ahead and actually create a container. So I have a command up here. We're going to create a new container. We can see that the data that I'm sending it is, I'm saying I want this container to have the name Redis and use this container image, Redis latest. So I'm going to go ahead and fire off this. Cool. There's not a lot of fanfare. And if I list out my running containers right now, we're not going to see anything running because, again, all I'm doing is just saving desired state for the moment. There's nothing acting on this data yet. So if I go ahead and like fetch these containers back, I can see the objects that I sent to it previously. So pretty bog standard CRUD API. All right. So here's where things are going to start to get interesting, which is when we throw our controller into the mix. So this controller is also just using Spring Boot. I'm using this, I added this little, where are we at? Using this like quartz library just to handle just that periodic triggering of jobs in the background because the controller doesn't expose any API endpoints here. This one has a few more files to look at, and we'll just kind of blow through them real quick. First of all, this has the exact same container definition that the server does. I was lazy and I just copied and pasted this one. I didn't feel like pulling it out into its own library that the two could use. So the exact same definition. We have our application, like the entry point here, where I'm just doing some, like specifying some beans, basically just giving myself 2 HTTP clients that I'm going to need. I'm going to need a client for communicating with the server, so an HTTP client for talking with the server. And I'm also going to need a client for communicating with Docker. Docker also exposes an HTTP endpoint through a Unix socket, and there's ways to turn it back on. But HTTP, just pretend it's HTTP. So I have 2 HTTP clients that we're using here. And if you remember, we were talking about how these controllers are going to like reconcile state. They're going to calculate actions that need to happen. So I have a few definitions for some actions here. So this controller is only going to do one of 2 things. It's either going to create a container or it's going to delete a container. I have this record representing like the kind of action that I'm taking plus which container I'm acting on. So 2 really straightforward record definitions. So let's go ahead and kind of jump into this controller implementation. I was trying to be very explicit about adhering to some of this terminology that we're talking about in the slides. So I have this reconcile method that is running every second, so 1,000 milliseconds. So that question about polling versus not, in these examples, everything's polling. So every second, I am going to ask the API server, what are my desired containers? I am going to ask Docker, what are the containers that are running? I'm going to figure out what needs to happen. Do I need to create anything? Do I need to delete anything? And then I'm going to go ahead and act on those things. So I don't want to get too caught up in the implementation of all of these methods. If you're curious about exactly how I'm doing those things, you can kind of peek in them yourself. But essentially, it's just all, get this response, retrieve, map to this other thing type codes. Process actions is where probably the more interesting stuff takes place, which is where we're actually interacting with the Docker API to like create a container or delete a container. So I am going to start running this controller. And if everybody remembers, in my current desired state, I'm saying I want Redis to be running. Redis is not running. If I say Docker PS, we can see it's not running. And just to make this a little bit more visible, on the left side here, I'm listing out the containers that are actively running. So it's just my database that's running right now. When I start running this controller, it's right away going to start asking the API server, what containers do I need running? It's going to see that Redis is not running and therefore is going to start running Redis. So let's go ahead and go through that. So let's start it up. Controller, and we'll say Spring Boot run. So this fires off and yep, already. So like it started up and right away it saw that there was something I needed to do. It told Docker, go ahead and start this container. And so it did. And we can see it's using the image and the name that I specified in my desired containers. Now, here's a cool trick that your infrastructure as code tool might not be doing for you. If I were to go now and manually delete that Redis container, so I'm not going to interact with the API. I'm just going to just kill it. I'm going to use Docker, remove this thing. What is going to happen? Well, the next time that controller wakes up, asks for the desired state, looks at the actual state, sees that something is now different, it is going to reconcile that state. So if you want to think of Kubernetes as this like continuously reconciling infrastructure as code tool, you're not too far off of what this system actually is doing. So we can see that I have this Redis container that's running. I'm going to stop it. And I am going to remove it. And in fact, we can already see that timing was really poor for demonstration because it started up right away. I'm going to try to catch it at a different time. So it's borderline really difficult, actually. I should have extended the polling time here. But every time I go and delete this thing, my controller is saying, this needs to be running. So to me, this is a very cool concept, right? Like these systems are continuously monitoring the state of my system and applying changes to bring my actual state closer to my desired state. So that also means that if I use the API to delete my desired container, the controller will then shut it down. So I'm going to go ahead and delete this container through the API. So I'm going to delete this through the API. It's going to clear out that entry in the database. The next time the controller wakes up, asks the API what containers need to be running, it's going to see that there's no containers that I want running, and it will delete the one that's already running. And just like that. And now if we do Docker PS, we're going to see that I'm just back to my database running again. Hopefully seeing the code in action kind of brings some clarity to this like closed loop control system, right? Like I can interact with either desired state or actual state. I can change one of these things. And this control is here to constantly make sure that these two things are equivalent to each other. So this is the simple netties. If you're tracking, you understand Kubernetes, by the way. So before I carry on and we talk a little bit more, start building on this idea, are there any questions before we kind of move on towards the next demo? Okay, so far so good. All right, so let's jump back to the slides. So one thing that I would like to address is this whole, like the big, scary, dangerous Y word, YAML. Again, also kind of carries, has some notoriety within the tech community. Kubernetes is a JSON API at its very core. Now, you don't have to use YAML. So if you're ever in a situation where you're interacting with Kubernetes, you have decided to like excommunicate YAML, never want to touch it again, you are perfectly able to do that. Much of the ecosystem and tooling is built around YAML, so it might make things harder for you in some sense. But for the remainder of this, like just bear in mind, Kubernetes is a JSON API, and the YAML won't hurt you too badly. Okay, so that question about somebody had made a question about like a container controller, which is true. We have one of those, and I would say like a huge challenge in learning Kubernetes is the terminology. So what I've overlaid here are the words that the Kubernetes docs uses for these things. I like my words a little bit better. Because when you hear kubelet, don't you just think, oh, that's a container controller? Like, how obvious is that? And this interface, this is the container runtime interface. This is not just an HTTP API, CRI. And the database, it doesn't use Postgres. Most clusters are using this database called etcd. And Kubernetes does introduce its own concept of this concept called a pod, which is really one or more containers. I'm not going to get too deep into that, but when you hear pods, I think it's safe to say for this presentation, pod and container are the same word. So a lot of terminology to learn, but conceptually not much more than this. And the other piece that takes some time to learn is learning about all of these different controllers that exist in the system, because there's not just one, there's a whole like family of controllers that are running. I don't know what you would call this, like a gaggle of controllers or something like that, a pack of controllers, but I just kind of like put representative icons on here for like a table that manages foo resources and bar resources, and we have their corresponding controllers. So Kubernetes does adhere pretty strongly to this philosophy of like, do one thing and do it well, because each controller is only governing one resource. Typically, some might be looking at more than two, but very commonly one controller, one resource. And so if you're ever in a situation where, heaven forbid, you're having to diagnose a cluster, it makes it pretty easy to block out things that you don't have to look at if you know the resource responsible for whatever you're trying to do. And I will say, like, good job, us. Like, this is the block diagram from the Kubernetes website. And it's pretty close. I would think it's pretty close to like what we've actually built together here. Flip it around, though, that's pretty much the only difference, but this is Kubernetes. So if you thought this was interesting, like, hey, all right, I'm down with this. I can get on boards. I can maybe get over some of the terminology. The rest of learning Kubernetes is all about just like learning these Lego pieces, learning what these different resources are and what their controllers are responsible for. So, for example, a pod. There is a pod controller. This controller manages groups of containers. Simple Netties, what we just built, is this. There's a service resource. This one's a little different. The controller for the service manages networking rules and DNS records. So you can see how things start definitely breaching into like more into the infrastructure worlds as we go along. We have a deployment which this controller manages your replicas, like pod replicas, and this thing is responsible for rolling out changes to pods. There's even really fun verbose ones like persistent volume claim, and this controller provides storage so that the controller is responsible for like provisioning storage that we'll use. There's even some that aren't even like interacting with like infrastructure directly, like the ingress resource, for example, is just like creating config files for you. So the controller for the ingress resource, for example, just creates an nginx config. So not all of these controllers are actually doing API calls and whatnot. Some of these are just changing files on disk. My favorite resource is employment, of course. That's a pretty good one. But really, my favorite resource is this also verbose one called the custom resource definition. This one you'll see very commonly abbreviated to CRD. And it is like the coolest controller, in my opinion, because This controller, in response to a resource, creates a whole new table in the database and exposes some CRUD API endpoints for you. Like, it is basically your database migration and code change in like one YAML file, which I think conceptually is very interesting. So let me expand on that a little bit more. So I have a client. I want to create this like foo custom resource. So I go ahead and I post my custom resource definition to the API. And in response to that, we get a brand new table in the database. And furthermore, we're going to get some new endpoints. Like my API server will change itself as it's running to expose new API endpoints. So it doesn't stop running. It's not like it shuts down, changes some things on disks, some like XML file or something like that. Just like as the API is running, we're going to expose some new API endpoints. And to me, this is like the other kind of massive big idea with Kubernetes. In addition to the closed loop control systems, the API is dynamic. It changes itself at runtime. Go ahead, Neil.
Question in the chat. Could you give an example of something you might have created a custom resource for?
This is a perfect segue. And actually, if you can hold on to that question for like 3 slides, I think 1, 2, 3, 4. 4 slides, I will give examples of custom resources. And that is also the second example. We are going to create a custom resource. So hopefully that will be a satisfying answer when we get to it.
Thank you.
Okay, now, cool. So what does the CRD look like? It's probably some awful gobbledygook. Well, depending on your perception of OpenAPI v3, maybe it is. But if you can like pull up a Swagger or have like written a Swagger doc, or maybe looked at one that was auto-generated, CRDs are just built around OpenAPI v3. So this is kind of neat. I'm sure every like product owner would love to have this ability to say like, here is the API spec that I want you to implement, and then do it. And that's what a custom resource does. Here's the API spec I want you to implement, make it happen. So we're not really going to look at it, but just know that this is like just compliant to the OpenAPI v3 schema. All right. I want to give like 2 more definitions of things before we carry on. First of all, in this next example, we are actually going to look at some real Kubernetes resources, some like real YAML manifests here. And I just kind of want to like draw some boundaries over some of the things that you're going to see. First of all, every resource is going to start with these kind of like top 3 fields: API version kinds, metadata with the name inside of it. These 3 things together is what is determining the API endpoint that we're going to call. So putting this in my YAML file is basically supposedly shorthand for spelling out what API endpoint that I'm calling. The next thing is most resources are then going to have a spec field, and the spec field varies depending on the resource itself, because this is my desired state. This is like if you're a Terraform user, like this is what I put in like these HCL files, right? Like this is my desired state, what I want to have happened. And then you're going to see there's also a status fields. And usually this is where the controller puts observed state in. So if you want to know what the controller's seeing or know what the controller's thinking at any point in time, I can look at my resource, look back at that status field, and get some insight into what the controller's thinking. So very useful for debugging stuff if things go wrong. I did see that somebody added a dot, and I didn't know that that was possible with Zoom. Does anybody know how to clear that? Or maybe I'm hallucinating that. No, that dot's definitely.
I see it too.
Okay.
Yeah. I have no idea where that came from.
Maybe I added it. Okay, apologies. I don't know how to get rid of that. Last definition I'm going to throw at you, and then we can like close the book on the dictionary. If you're looking within, like if you start Googling Kubernetes controllers, custom resource definitions, you are going to run into this word operator. I don't know where they came up with operator, so I can't like give you a cool explanation for that one, but an operator is a custom resource definition with the controller. So the controller on its own is just that piece of software that's implementing that closed loop control system. The CRD is that definition of the resource itself. And if I have two of those things, if I have both of them, that is an operator. And so that question about what are examples of controllers, I will rephrase that to what are example operators that you'll find. And I threw down some like commonly used ones or ones that I've used on projects myself. So cert manager is an operator that manages TLS certificates. So if you just really don't want to deal with HTTPS, like the S part of HTTP, cert manager takes care of that for you. So it'll like communicate to Let's Encrypt for you, or like whatever other private key for PKI that you have set up, and provision those certificates for you. So I can just ask for a certificate in YAML, and it just gives it to me. Pretty cool. There's a Postgres operator. So if I just want to run like a clustered Postgres with automatic failover and backups, there's an operator for that. So I can just create the resource and it sets all of those things up for me. I don't have to do that manual tweaking all on my own. Kubernetes stack. So if you're somebody that's using like OpenTelemetry, for example, or like the whole Grafana set of observability tools, Kubernetes stack is another operator that pretty much sets all of those things up for you. So it'll deploy Prometheus with Grafana, and you can throw like all of the other Grafana tools in there, like Loki and so on and so forth. So these are just some of the probably more common or more popular operators out there. And we're going to build our own. This is kind of like the final demo that we're going to go through. We're going to build an operator that just rolls some dice. And so this is like arguably the most complicated random number generator that we could come up with. But I think it's a good for demonstrating some stuff. And also if you're a D&D nerds, you might be able to derive some enjoyment out of that as well. So, okay. We're going to now look at the code example for operators. And we're gonna build one ourselves. So this example is under the dice roll operator folder within this repo. So this has its own README, kind of talks you through like, what is it that we're doing? How do you create a cluster locally? By the way, to me, this is like one of the things that made like really appealed, or this was one of the really appealing things about Kubernetes to me when I was getting started, is that I don't have to give a credit card to anybody. I could just like run a cluster locally. I can break this thing and restart it over. Very, very convenient for learning things. So you can just run Kubernetes on your machine. Docker Desktop also makes that incredibly easy as well. In this example, I'm using Minikube. All of this code I wrote in using code spaces, and the like default code space image already has this tool installed. So that's why I chose this one. So this walks you through like creating the cluster, sending some of these manifests over to the API server. When we say sending a manifest, what we're really saying is making an HTTP call to the corresponding endpoint and shoving that JSON body in the request. So if you see, like anytime you see this like kubectl, kubectl, kubecontrol apply, these are HTTP calls that we're making. And then there's like some, if you want to run the controller from outside the cluster versus inside the cluster, I kind of walk through that. So let's go ahead and jump over into VS Code here and pull that example up. I guess before I go on, I'm going to shut down these other examples, Simple Nutties that was still running. And I'm just going to take the database container, remove that. Okay, so dice roll operator. So we're going to roll some dice. Whoops, readme. Okay, so first things first, I need to start the cluster. So I'm going to run minikube start. And this is going to run Kubernetes for me. Just wait a few more seconds. All right. So real quick, let's take a look at something here. kubectl. I'm going to like fire off this command, which I don't want to get too deep into what this is actually doing. But what I do want to show is I'm asking for this cluster for like, what are the containers that are already running? And we can see etcd, the database is running, the API server, the controller manager. So when we were talking about, and when I was saying, like, if you understand this block diagram, you understand Kubernetes, well, everything we just talked about, you can actually see within the cluster itself. Controller run, the controller manager, API server, here's the database. These other containers that are running right here are some other controllers. This one manages DNS records. This one takes care of the fact that Kubernetes can like cover multiple VMs, which are called nodes. This one handles storage provisioning, etc. So we can see that these are running. So I just thought that would be kind of cool to show real quick. All right, so let's look at our custom resource definition. All right, so underneath this manifest directory, we're going to see the CRD YAML here. This contains the actual definition of our custom resource. So again, we're going to see a little bit of this boilerplate, API version kind metadata, which API endpoint am I calling? What is the name of this resource? And then the spec. This is the desired state of my custom resource. Like, I want you to create this table and these API endpoints that adhere to the Open API v3 spec that I'm going to give you right here. So if you've ever seen one of these before, hopefully it looks kind of familiar. These custom resources are all going to have a spec and status fields. Within the spec fields, that itself is also an object that pretty much just has one field, dice, which is an array of strings. Strictly, these are strings that pull from like this enumerated list. So it's going to be one of like the D&D dice, and I threw a D100. I don't know if D100 is like canon, if that exists. Somebody who knows D&D better maybe could throw it in the chat, but I thought that was fun. So yeah, basically, when I create a dice roll resource, when I create one of these things, I'm going to tell the controller which dice do I want to roll, and like basically the list of dice that I want to roll. And then in the status fields, which is what the controller will change, the controller is going to give us the total that was rolled, as well as just the individual rolls. So if I needed to know if I got like a nat 20, for example, I will be able to see like all of the individual values that were rolled. Okay, so desired state, here's some dice I want to roll. Actual state in this case is just what we're throwing in the status field. So here is like what the results of rolling those dice were. So I'm going to go ahead and, whoops, we pull up this one. Before I move on, and before I apply this resource, I am going to expose the Kubernetes API directly. Here we go. So this command is basically just exposing the API server directly to the outside world. So I don't have to use this like CLI tool to kind of like take care of stuff for me. And it also uses some credentials that I have to expose it locally on my machine. And I'm just going to like pull this up in the browser. Whoops, that was strange. Localhost 8001. There we go. Okay, so I just made a request in the browser. We can see that the Kubernetes API is also self-describing. It is telling us what are all the API endpoints that it exposes. So basically, what are all of the resources that are already available in this cluster? We can see there's already quite a lot of resources that come with this cluster. Let's just look at one for fun here. Maybe I will do the request. What will be the endpoint for our custom resources? So right now, if I try to pull up this API endpoint, we get a 404. This is the API endpoint that represents these dice roll resources. I haven't created that CRD yet, so it makes sense. There's no API endpoints for this thing, 404. Let's go ahead and apply our custom resource. So here we go. So it's up and dice roll operator. Whoops, that was the wrong manifest. Delete those. I meant to apply the CRD one. Apply. There we go. Okay. Sorry for that mistyping. Go ahead and apply that CRD. So now if I refresh, well, all we get is we get a fancier 404 because I've asked for a specific dice roll, but now we can actually see the API knows what dice roll resources are. So by making an HTTP request, I've changed the endpoints in this system, which is kind of cool. And I could actually ask for like the list of dice rolls that exists by manipulating this a little bit. Right now, I have no dice roll resources that the API and the controller are managing. So it's just an empty list of dice rolls. Okay, and also just proof that the Kubernetes API is a JSON API. The fact that we're not getting this back as YAML, we're just getting JSON bodies here. All right, so now we're going to go ahead and run our controller. So this controller is going to communicate with the API. It's going to effectively be making calls to these exact same API endpoints that I'm showing you in the browser here, fetching that desired state, and then if it finds a dice roll resource, it's going to do some random number generation and then set those results into the status. So let's go ahead and run this example. And okay. I haven't created a dice roll resource yet. So if I refresh, we can see there's nothing here. But let's go ahead and create an example dice roll resource. So here is an example dice roll resource. I'm going to call it my dice roll, and I want to roll a D4 and a D20 in this example. So let's go ahead and Control apply. And whoops, as I do this one, I am also going to ask this CLI tool to show me what is the underlying HTTP traffic that's happening when I ran this command. So example dice roll. So we got a lot of output here, and it's actually kind of hard to see in the zoomed in view. But when we made our request, we can see, I mean, it's kind of neat. It just straight up tells us what would have been the curl commands that I was executing when this exchange was happening. So if you really want to deconstruct the magic, you can just ask for the HTTP requests that are going back and forth, and it gives you the headers, response headers, the body, et cetera, et cetera. Okay. So I have now created a dice roll resource. I'm going to refresh this page, and we should see something new appear here, which we do. And not only do we see something new, we also got some results of rolling those dice. So my D4 came back as a 4. My D20 came back as a 13. 13 plus 4 is, wow, this was really bad math. No, this is right, 17. Sorry, I was looking at the 20. I was thinking, how did I mess that up? So yeah, total 17. So in this case, this operator that we built, this custom resource, the actual state is some random numbers in status. And just like everything else we've talked about, if I were to now like go ahead and like delete the resource, for example, maybe we try to delete this through the API endpoints. That would be kind of fun. Creating, I think I had an example of that in here. Did I not? No, just creating the resource. Okay. Let's see if we can like cobble that endpoint to that curl call together ourselves. So curl x delete this. Yeah, perfect. And already it's already refreshed and said that this resource isn't found. So there we go. Before I have a couple more slides, but before I carry on, any questions? This was definitely a little bit of a leap in the example, kind of in some of the understanding. But what I was hoping to demonstrate is that without getting too bogged down into the details, that with Kubernetes, it's possible to like make a request and create a new database table and API endpoints all in one go, and it's declarative. So if I wanted to like change that schema, change these API endpoints, I can introduce new versions of my custom resource. Okay. It's either a really good sign or a really bad sign. So let me, oh no, play from current slide. Let me just cover the last couple things here. And we were over here. There we go. Okay, so personally, I think this is a really interesting idea. Like the fact that if I just have these like components of Kubernetes running, I have this dynamic API with database migrations and like schema validation and all of that happening for me. And like, could I just have a really, really simple API and pay Amazon, like whatever it is, $75 a month, I think, for a managed control plane, EKS, which they're responsible for scaling and keeping up, by the way, and just have an API that's just the Kubernetes components, because like these managed services are responsible for the database, for the API server, for these like built-in controllers and whatnot. So funnily enough, Amazon already beat me to that thought, not surprising. They had a whole blog post that kind of like talks about this idea of Kubernetes as a platform versus Kubernetes as an API. When people think of Kubernetes, they're approaching it typically from this platform perspective, but there's a lot of interesting things that you could do when you start looking at it from this API perspective. So they start going through all these different use cases and whatnot of like, what can you do with that? And there are like other controllers, operators in the ecosystem, Crossplane, for example, that is attempting to basically be the like Kubernetes version of like these Terraform providers or of like CloudFormation and stuff. So they are already creating a resource and a controller for all of the different products and all of like the major clouds, for example. So if you thought this was truly cool and I just want to do everything in Kubernetes, Crossplane will make that happen because I could just like create an EC2 resource and it will like provision the EC2 resource like instance for me. So just a quick recap. Big ideas. Kubernetes is an API. Clients provide the desired state. Controllers perform actions so that actual state matches desired state, and the API can change at runtime. These are kind of like the four big things that makes Kubernetes what it is. And if you were able to get to this end and not along for the most part, again, congratulations. You understand Kubernetes. And now it's basically a matter of going through the Pokedex of like custom resource or like these resources and controllers to know what all is possible. So yeah, what's next? All right. So as I said, if you thought this was cool, learned some more resources, tried deploying some apps. I didn't want to kind of repeat all of the documentation that you can already find on the internet. Like all the big cloud providers already have like really thorough tutorials on how to cover all of this stuff. As a quick plug, if you want to get deeper into some of the concepts behind Kubernetes, on the Source Allies blog, we also have a few different posts that covered that. I forgot to send those links to you, Neil and Akram, so I'll send that to you after this. Try using one of these managed products, EKS, AKS, GKE, even the smaller ones like DigitalOcean, Linode, or I think it's Akamai now. They have all of these managed Kubernetes services. If the idea of building an operator seems interesting to you, we did it very bare bones. Unsurprisingly, there's whole frameworks that help you like build these operators. So you're not handcrafting this schema. You define some types and it generates it all for you. It's all really nice. And then lastly, just again, shout out to Source Allies for sponsoring and for hosting and helping us get everything set up. So really appreciate that. Yeah, if you thought this talk was interesting, or as Akram was sharing, if you're looking for some new opportunities, definitely reach out to Carter, which was in the slides that Akram shared earlier. And then finally, I guess just live long and prosper. So any final questions before we call it?
Thank you, Ben. This was awesome. There was a lot of activity in the chat and questions, so that was great. But I didn't see any lingering questions. So if anyone has a question, feel free to unmute and pose your question to Ben. All right. I think this was very well explained that no one has any remaining questions. Oh, there's one. Do you recommend getting Kubernetes certified?
Do I recommend getting Kubernetes certified? Okay. So I have done, so I've done the CKAD, the CKAD, and the CKA as well. So Andrea, I'm unsure, but I've done both of those. I would say doing both of those, like the act of going through that certification and like having that syllabus was really useful for me to understand which parts should be focused on. Like, what are the fundamentals? Because I felt like when I go to the Kubernetes docs, it's just an overwhelming buffet of information that can be really difficult to wade through. So if you want to like learn and have that kind of like linear path through the material, I would highly recommend it. It really helped me understand exactly what's going on. Everything that I'm sharing with you is effectively what I learned from doing those certifications. Like personally and professionally, it's really made like working with Kubernetes really easy and fun for me. So if you're thinking about it, I would definitely recommend it. Yeah. So, and also if you have any questions about it, you can reach out to me on LinkedIn. And I can share my link as well. And I'm happy to answer questions about those exams. Are the CKAD and CKAD still done with a human tester? So just to expand on the certification process, and some people are interested. When you do it, it is virtual. So you can like pick a time when you want to do it, but there is somebody that proctors it. Kind of creepily, you can't see them, but like when you run it through their like testing system, you know the webcam's on, like you see the lights running. So it's nice that you could do it. Like I just did it in my house. It is not a multiple choice exam. So if you're familiar with like some of the other, I've never done it, but I've heard like some of the AWS certs, for example, are more like multiple choice type exams. It is a hands-on practical exam. So the questions are like, deploy an application that does this, and you're running the commands in the terminal that does it. So before you take the exam, just make sure you're feeling comfortable from the terminal. You do get to use the docs for reference though, so you don't have to like memorize everything. How can you
say what's the difference between the two certifications, the CKA and the CKAD?
Yep. So the CKAD, CKAD is Certified Kubernetes Application Developer. So that is looking at Kubernetes more from the developer perspective. So I'm somebody that's going to be building and running in Kubernetes applications on Kubernetes. And I just want to really understand deeply, like I said, that Pokedex, like that encyclopedia of resources that are available to me as the application developer. The CKA is kind of the ops side of this like DevOps ecosystem. So the CKA, Certified Kubernetes Administrator, is focusing on more of like the infrastructure type components. How do I set up my security policies? How do I actually like manage the VMs that my cluster is built on? That kind of stuff. So if you're an app developer and like you don't anticipate actually running your own cluster, the CKA is probably overkill. But if you're like a Linux guru and like you can just throw down some like systemd, like system control commands and stuff like that, you'd probably breeze through it really easy.
Thank you.
How can you know if Kubernetes will be useful or not for your applications? Any particular signs that you probably don't need it? That's a good question. I would say, like, first and foremost, if you are happy with your setup, you don't need it. So I wouldn't like just switch stuff over to Kubernetes just because. Um, I would use Kubernetes personally, for example, if I was planning on doing a like containerized, like deploying containerized applications where I was going to want to have more control potentially over the costs involved. at a large scale, just from experience, a large scale kind of like refined EKS cluster, for example, is going to be cheaper than the corresponding ECS kind of cluster that I'm building. But it's up to you to judge how valuable your time is. Amazon does a lot of things for you when you use that ECS product. But if you have people that are already familiar with the technology, you can go a little bit further for your dollar going the Kubernetes route. The other instance I would say Kubernetes, and where I've personally used it professionally, is if I'm doing something on-prem. I think it's a wonderful choice for on-prem if you're not too, like if that idea doesn't turn you off, because if you're already running stuff on-prem, you probably already have some variation of a sysadmin or ops team or something like that that's keeping some of this stuff afloat. Going down the Kubernetes path means I then get to use a lot of these, like, not to throw the buzzword out, but like a lot of the like cloud native tools that are being built, like what I threw out Kubernetes stack. Here's a tool that is well maintained, and it will manage like provisioning this observability tool suite for me. So if I'm bound in my on-prem environment, I want my developers that are deploying on-prem to have an environment that feels more like what I have in Azure or Google Cloud or AWS. That would be a great choice, especially because Kubernetes on-prem and Kubernetes in the cloud, it's just Kubernetes. So using that as like a transitionary pathway to the clouds could also be really useful. So hopefully that gives you some ideas of where it's useful. I don't think it's not like the silver bullet that's going to solve all your problems, but yeah, if I'm like really concerned about costs, or if I'm deploying containerized workloads and I want to use the ecosystem, or I want that flexibility across cloud providers, sorry, I know this is a really long-winded answer, but just to like expand on that, I was helping within Source. There's like an Azure community of practice, and they were looking at AKS one day. I don't know personally anything about Azure, and I went to join, and within an hour, we had something deployed publicly running on Kubernetes, not knowing any of the Azure stuff, because Kubernetes in Azure and Kubernetes in Google Cloud and AWS, it's just all Kubernetes. So that skill transfer was really good. Are there any online communities that you would recommend checking out while learning? Subreddits, blogs, etc. I would say the Kubernetes like subreddit, for example, is like mostly filled with memes. So if you're looking for a laugh, like that's good. There are, of course, like on GitHub, people put out those like starter paths for Kubernetes. I think those are okay. Personally, I'm just going to do a quick shout out. I like one of the tools that I was using, which is a paid product, was Code Clouds. And I thought the way they did it was spectacular, because it gives you these sandbox environments to like run all the commands, like see what happens. Like I'm running commands and you can visualize it all next to it. That really accelerated my learning quite a lot. But otherwise, I would say, without sounding too generic, just the like tip where you might typically find like your tech news and tech info. I would not necessarily recommend the Kubernetes docs itself. Surprisingly, they are an amazing reference. If you know what you're looking for, they are fantastic. But for that like beginner structured learning path, I really struggled with that. Strong overlap between Kubernetes and memes. Well, yeah, I would say nerds and memes in general. So So thank you. Yeah, and I guess I don't need to keep sharing Spock here. So yeah, oops, still sharing. There we go. And yeah, I'll have Akram or Neil, I'll share my LinkedIn. If people have more questions or anything like that, definitely feel free to reach out.
Thank you, Ben. This was awesome. Just need a second or so to bring all of my Zoom windows here. So for the final part, we're going to raffle out the JetBrains IDE license. So I have put everyone's name in here. Unfortunately, to claim this, you need to be here because I'm gonna need your email address. So without further ado, we're gonna spin the wheel and see who's the lucky person. Oh, it's Jeffrey Roberts. Are you here, Jeffrey? So I will want you to, in Zoom, if you can DM me your email address, I will forward the license to you. Congratulations. I'm gonna, there's always a risk of ending the Zoom call and then we're not gonna be able to reach each other. So if you can just type it in into the chat. Thank you. Got it. I'm just gonna put it here in the notes. Sweet. Thank you, everyone. I'm gonna stop the sharing and the recording. If you can give me a second.